So a box with mass 20 kilograms. So let's start with a little box here. And, whoa, that escalated quickly. No, what's going on? Yep, as you can tell, the drawing is not going well. All right, we're just going to start again. Okay, there's my box. Okay, so now we're going to start putting some forces in there. So there's my normal force. There's my weight force. And it tells us as well that there is a rope that connects going up here 45 degrees. So there's all the information that I've currently got. Now I can start putting my numbers on my graph, on my picture. So this is the normal force. We're going to call this the rope force, or R. And this is our weight force down here, which is 20G. So first thing I can see, and the acceleration as well. So the acceleration is 0.5 meters per second squared in the I direction. And your acceleration is 0 meters per second squared in the J direction. Okay, so first thing we're going to do is we're going to start by finding what our force actually is. So in the I direction, force equals mass by acceleration. So that means our force is equal to 20 times 0.5. So the force in the I direction is 10 newtons. In the J direction, our force is equal to mass by acceleration. So our force is equal to 20 times 0. So that means that the force in the J direction is equal to 0 newtons. So next thing we want to do is we want to start looking at our forces. Now, I know normally I would jump straight to doing N minus this one plus this one going in that direction, but that's because normally we're told what the tension force is on the rope. But we're going to have to determine that one for ourselves. So I'm going to start by filling in my information. Okay, so this is going to be my opposite. This is going to be my adjacent. So if I look at the I direction first, okay, so if I look at the I direction first, that means that I'm looking at this force only. So the force that goes in that direction, in the I direction, should be equal to this. So 10 equals, now because that's the adjacent, it's going to be our R, tension force, cos of 45 degrees. So 10 is equal to R root 2 on 2. Take the 2 over, it'll become 20 divided by root 2. Now all that's left to do is rationalise my denominator by multiplying the top and the bottom by root 2, which will give me 20 root 2 on 2 for R. So then R is equal to 10 root 2. Now I had to do that step first, and if you tried to do just the J components first, you would have noticed that you were missing this R force, so you would have known you had to go back to find it. Now I can do the same thing, but for these forces. So there's that force, there's that one, and then there's this one going up here. So, J forces. So I'm going to, they should all be equal to 0 because that's our force in the J direction. So 0 is equal to the normal force minus the weight force plus our R, so it's 10 root 2 sine of 45 degrees. So that means that 0 is equal to N minus 20G plus 10 root 2 times root 2 on 2. Now, these two would turn into a 2, and then they'll cancel. So I'll be left with 10. So I can express my normal force as, now when I take this over, it would become negative, meaning that all these signs on this side will change. it will become 20g minus 10. If this is tech active, I'd put it into the calculator and get a real answer there. They've just chosen to factorize out the 10 to display it like this. But that's how you do it.